we have things that Einstein is credited for, and which he probably did not really invent, or nothing. These things did not come out of his brain. And so here's a summary of that, okay, just so that you can see where I'm headed with all this. Einstein was born in 1879, so he was 8 years old when Michelson and Morley ran their experiment on the ether. Heaviside, a year later, 1888, Einstein was 9 years old, and he started questioning, whether the ether existed or not. He was on the side of the ether. He didn't want to reject it. Everybody in those days had been born with the ether, and they couldn't do without it. Like everybody today is born with space-time. They can't do without it. Okay? And you have all these people, Fitzgerald, Lorentz, and Poincaré, and so on. And so Einstein did not discover a lot of this stuff because it was discovered by all these other fellows. But nobody knows these guys today. I mean, you talk, just stop anyone on the streets and ask them, do they know who Heaviside is, or Fitzgerald, or Lawrence? And they'll say, no, who the hell are those guys? And you ask them, do you know who Einstein is? And I'll bet you everybody out there knows the name Einstein. Whether they know what he did or not, I don't know. But they'll know the name Einstein. But nobody knows these other guys, and these are the fellows who really came up with a lot of this stuff. Okay, and so this is what we have to look at, whether Einstein contributed. What did Einstein contribute to physics, to science, to even to mathematical physics? Forget about science and physics. Mathematical physics. What did he contribute? And this is what we're trying to look at today. Was his life worth anything? Okay, and here are a couple of examples. Okay, Einstein showed that the universe does have a speed limit. The speed of light in a vacuum is 300,000 kilometers per second. And he said there's a speed limit. But he says the faster an object travels, the more massive it becomes. Absolutely not. Accelerating object gains mass and thus becomes heavier. Absolutely not. Mass is defined as the quantity of matter, or a measure of quantity of matter, or whatever you want to say there. And it has nothing at all to do with speed. Okay, so the speed should not affect the mass, which is how many atoms an object has. The fact that a dog travels close to the speed of light should not change the amount of the atoms in his body, unless you can come up with a mechanism to say how he lost or how he gained more atoms, right? In this case, gained, right? And so the question is, did the amount of matter increase? And again, Einstein, like all mathematicians, they don't know the difference between weight and mass, or better yet, there is no difference because they were never able to isolate weight from mass. That's the issue. Okay, and they're treating something known as weight, and they're treating it as mass. They're calling it mass. That was the problem there. But this is one of the things he came up with, supposedly out of his mind. And here's another one, real quick. Okay, Einstein time, right? He held that one person's past could be another's future. Okay, so your past is my future, vice versa, I guess. It doesn't matter. But see, all this has to do with observer, with testimony, with opinion, with religion. It has nothing to do with physics. They're talking about testimony, about being a witness. Okay? And so whether your past is my future, you could be drinking a lot of beer and you lost track of time. What does this have to do with anything? Time has nothing to do with physics. We don't use the word time in physics because time is a mathematical concept. It's a numerical concept, and in physics we do explanations. We have to do physical interpretations. We have no use for the word time or any value of time. It doesn't help us explain things. Okay, you can describe things with time, but you cannot explain, and people don't always understand that. Okay. And what we do against time is put the universal movie. Okay, there is no such thing as time. What we see is only atoms in a cross-section of motion of time, meaning a single frame of the universal movie. We take a snapshot of the universal movie. We just stop everything in place. We freeze everything just to conceptualize the universe, and all we see in that single frame is particles at different distances from all others. In other words, whether you're talking about galaxies or stars or planets or better yet, atoms. Every atom in the universe is in that single frame at a given location with respect to all other atoms. So that's what it is. There is no time in a single frame of the movie. If you want to see time or motion, you got to go to the one on the bottom. See, the one on the top in yellow there and blue, that's only static concepts that you'll see in a single frame. All the others require a movie. You require more than two or more frames of the movie. Okay, and so when these people talk about time, well, they're talking about something that's on the bottom. You need to watch a movie to conceptualize time. In a single frame, that's Father Universe there in a single frame, all atoms at a distance from all others. There is no such thing as time. And therefore you cannot time travel or do anything of that nature, because to do so means that you would have to go to a previous frame where all those same atoms still are in there. And there's no such monster, because that would mean that every atom in the universe, instead of moving to a new location, you're creating a copy of that atom on the next frame, and then on the next one, and on the next one. And that's the only way you can go to the previous frame where you still find atoms. No such thing. Father Universe does not keep track of all past events. We always exist. Every atom in the universe only exists in the present. So there's no such thing as time. So to talk about time travel and time dilation, all that other nonsense, has nothing to do with anything. Where'd they get all this stuff? Einstein, especially. Well, as far as I can trace it, okay, maybe someone can correct me here, but as far as I can trace it, it comes to this guy, Voigt, Valdemar Voigt, and he came up with that factor. 1 minus v squared over c squared. And that's the only factor you need to know in all of special relativity. Why? Because that factor there, that's the one they're going to use for length contraction, for mass increase, for time dilation. All that stuff is done with that factor. So once you understand that factor, you understand special relativity, the mathematics behind special relativity. Okay? And he wrote about it in 1887 when Einstein was only 8 years old. He was still sucking his thumb, right? So Einstein did not come up with that factor, and that's what makes special relativity work. Okay, that's what everybody based their mathematics on, that specific factor. You understand that, you understand everything, because you got the velocity of the object. The closer it comes to the velocity of light, the closer that goes to 1, right? 300,000 over 300,000 kilometers per second, right? Then you have 1 minus 1, you get 0, and the square root of 0 is something the mathematicians call infinity, whatever that is, right? And so the issue is when you use this factor and you put it as a to multiply or to divide, you're going to create all these effects that are, special relativity is famous for. Okay. And here's one fellow who used that factor, and his name was Lorentz, okay? And he's really the guy who you could say can be credited as the originator of relativity theory, okay? It was there before Einstein. And again, all these people wrote in the 1890s all the way to the 1900s. By the time Einstein comes and writes his first few papers in 1905, these guys had already played around with these factors and equations and so on. So how much of this can be attributed to Einstein? I don't know. You figure it out on your own. Okay, but my take is that he cannot be held responsible for a lot of the stuff he is being credited for today. Okay, here we have another example of relative motion, and he says whether an object is at rest or in motion depends on what? Your point of view. Frame of reference is really just a physicist, really mathematician, way of describing someone's point of view. Well, that's observer-related testimony. We're talking about witnesses, opinion, religion. This has nothing to do with science, okay, or with physics. We don't have opinions in physics. We just present explanations, physical interpretations of what happened, a mechanism, so that you understand what how gravity works, how magnetism works. We want to understand that. That's what physics is about. Okay, and so here we have all that came from. Two fellows who already talked about that earlier, and one was Lorentz, the other one was Poincaré. And it says in 1904, Henry Poincaré called local time Lorentz most ingenious idea and illustrated by showing that clocks in moving frames are synchronized by exchanging light signals that are assumed to travel at the same speed against and with the motion of the frame. And with that, he essentially had the same idea that Einstein was going to borrow later on. And it turns out, George Fitzgerald had already talked about that in 1889 when Einstein was just 10 years old. So, I can't believe that Einstein came up with all this stuff. In fact, here you have someone who illustrated it. See if I can put this up here. Who illustrated what these people are talking about, the fact that observers see different things or measure different things, right? Because they're in different moving frames. Okay, so and you see that the guy who's rolling there is Lorentz. Einstein's the guy who's doing the observing, or from this end at least. So, all this already was around before Einstein came up with all this stuff. He gets credit for all of that. Nobody remembers who Lorentz is. No one on the streets, at least. And again, it's because everything in special relativity has been given to Einstein. He took the whole treasure chest. Okay, he's the guy who did it all. Here we have another issue. Okay, the speed of light is constant, Einstein said. Beams of light from a speeding car's headlights travel at a constant rate despite how fast the source moves. So we have two issues here. First, he's saying the speed of light is constant, doesn't vary. And what that really means is that irrespective of the source of that light, moving train, everybody thinks about usually, the portion of light will always travel at the same speed, always 300,000 kilometers per second. You don't add the speed of the train to the speed of light. And, whether you accept that or not, that's not the issue. The issue is that he's not the first guy to say this. Here you have from the Wikipedia again, Lorentz, he said the velocity of light is totally independent of the velocity of the source. He had already said that in 1892 when Einstein was 13 years old. And 1898, he was a little older now, but Poincaré says light has a constant speed and is the same in all directions. He had already mentioned this. He already knew about this. It's not like Einstein discovered this stuff. Okay, so I'm just whether you agree with what special relativity says or the mathematics of it, irrelevant. I'm saying that Einstein wasn't the guy who created all these ideas. Okay, he did not originate these ideas. He's given credit for them today. And again, what we're looking at is Einstein's contribution to science, to physics. Mathematical physics, none of them contributed anything, even to this day. Okay, here's another famous thing that's attributed to Einstein. It's known as the equivalence principle, okay, principle of equivalence. And it says gravity and acceleration must be equivalent, and it's called the equivalence principle. It says that Einstein was given credit for that. The question here is whether this has anything to do with physics. And the reason I'm asking is because he did not explain why. I mean, the fact that he did a mathematical calculation or there was a measurement and he reached that conclusion, so what? Why is there an equivalence? That's what he's got to explain. Why, gravity and acceleration, why are they equivalent? And we do have an explanation for that, okay? And here it is. We've talked about it in the past. I'll just go really quickly through it. Okay, an atom, and here we're freezing the universe again, right? And an atom, which is at the distance from the Earth, at a given distance from the Earth, whether it belongs to an elephant or a feather, that atom weighs the same amount. Why? Because at that location, right, it's got a certain number of effective ropes bearing upon it. Okay, so the number of ropes is the same for any given atom, and we're talking about, in this case, a hydrogen atom, right? To make it simple. An atom has a certain number of ropes converging upon it from every atom on Earth at a given location, around the Earth. It doesn't matter what that atom belongs to. Okay, so that's where we start. And then we top that off with this, the equivalence principle. Here it is. It doesn't matter whether the atom's running away from the Earth or coming towards the Earth, right, which is the scenario Einstein presented. That atom has a certain number of ropes converging upon it at a given distance from the Earth, whether it belongs to that elephant there or maybe even to a feather or whatever. Doesn't matter. An atom at a certain distance, whether it's going outwards or coming in, it's the same number of ropes converging upon it. That's why the equivalence, that's the reason behind, that's the physical reason behind the equivalence principle. And we don't have to do any measurements. No measurements required, okay? We don't measure these nonsense. They say we measured it to almost to precisely gazillion decimal points, and they seem like they're quite accurate. Yeah, it's exactly the same. You don't have to measure anymore, please. They're exactly the same. At a given distance from the Earth, that atom has so many ropes converging upon it. And our dear friend Richard Muller, professor at Berkeley, said, every atom in your body is bound to is being pulled by every atom on Earth, and every atom on Earth pulls on every atom of you. How do you pull without a mediator, an elongated mediator? So hopefully there's an elongated mediator binding any two atoms, from you and the Earth, at least that much, right? And if that's the case, you have to identify that mediator. And if you say there's no mediator, there's nothing there because I can't see or touch it, well, then you're going to be doing action at a distance, meaning you're doing black magic, you're doing witchcraft. A lot of voodoo science. Okay? Okay, what did Einstein have to say about energy? Einstein's energy, he said E equals mc squared. Right. Okay? So is this important? Well, I mean, what's the point of this if energy is not defined and neither is mass defined? They haven't defined either one of these two words. Neither one of them is a physical object. You can say that the clay is equal to the statue once you mold it. Then you can say clay is equal to the statue because it's got the same number of atoms. Or it was just molded in such a way that this became that. Then you can say this is equal to that. What sense does it make to say that mass is equal to energy if you don't have a definition for either one of them? Both are concepts. What are you saying? They don't have an idea what mass is, as we just showed. They think that mass is weight because the faster you accelerate an object, the more mass it has. Meaning, it gained more atoms. What happened there? So they don't have an idea what energy is at all. It's just a value. So it's just numbers. And so what does that have to do with physics? What contribution did Einstein make to physics is the question, right? Here's one fellow who, this is first go to line, and getting credit for all the special relativity stuff. But here I have a fellow who summarizes essentially what the difference is or what Einstein contributed to mathematical physics, right? Math. Essentially, that these other fellows, like Lorentz and Poincaré, did not do. Okay, so here it is. He says, most of the components of Einstein's paper appeared in others' interior works on the electrodynamics of moving bodies. Poincaré, Bucherer had the relativity principle. Absolutely. Lorentz and Larmor had most of Lorentz transformations. Poincaré had them all. Kahn and Bucherer rejected the ether. Great. Poincaré, Kahn, and Abraham had a physical interpretation of Lorentz local time. Larmor and Kahn alluded to the dilation of time. Lorentz and Poincaré had the relativistic dynamics of the electron. What did they not do, which Einstein came in and take the credit for? None of these authors, however, dared to reform the concepts of space and time. None of them imagined a new kinematics. Okay, based on two postulates, none of them derived the Lorentz transformations on this basis. None of them fully understood the physical implications of these transformations. That was all Einstein. And yeah, the issue here is that Einstein is the guy who's going to introduce the physical interpretations. But what physical interpretations did Einstein introduce? Well, he introduced nonsense. He introduced warp number lines. They have nothing to do with physics again. So whatever Einstein contributed, that these guys did had to do only with math, or better yet, mathematical physics, meaning no physics at all. Meaning, that they did not do a physical interpretation. None of them did. Neither the previous guys, neither Einstein. So if these guys invented all the mathematical physics stuff, and Einstein was supposedly the guy who gave a new interpretation, physical interpretation, but none of it has to do with physics, then Einstein ends up with zero. He did nothing. He didn't do physics, he didn't do mathematics. Neither one, because the math was done by others, he just copied it, and he didn't do the physics part because none of what he came up with had anything to do with physics.